Now see here, in the principle of superposition only, if there are n number of charges are present in the system, suppose like q1, q2 and qn, then the total force acting on any one of the charge, that is suppose q1 we are taking. So we can write here F is equal to F12 plus F13 plus F1n. So total force on the charge q1. So we can write here also F is equal to q1 q2 divided by 4 pi epsilon naught r12 square r12 unit vector plus 1 upon 4 pi epsilon naught q1 qn divided by r1n square r1n unit vector. So we can write also in this form F is equal to, we can take common q1 here 4 pi epsilon naught sigma, here we can write here q1i divided by r1i square r1i unit vector, where I is equal to 2 to n. So this is the total force acting on the charge q1 due to the presence of the n number of the charges. So this is also here according to the principle of superposition, we can calculate net force acting on any one of the charge due to the presence of other charges. So now let us take an example here, which is based on the principle of superposition. Suppose there are 3 charges placed at the vertices of triangle AB and at A, B and C. These are the charges Q, Q and Q, all have the positive sign, and Q and Q. Sides of this triangles are suppose L, L and L. There is third charge placed at the centroid, that is Q. We have to calculate net force on this charge. So what is the force experienced by the charge Q placed at the centroid? So this is actually based on the principle of superposition. Now we know here in this triangle OA is equal to OB is equal to OC, triangle is equilateral, and now force on O due to A can be written here. This is your negative positive and this is positive, so that is the repulsive sign here, that is FOA. Force on O charge Q placed at O due to B is equal to this side, that is FOB, and force on charge Q due to C due to the charge placed at C, that is FOC. So there are the 3 forces here, FOA, FOB and FOC. Now we have to calculate the net force. So we can take here, I am making this diagram in the here in this way. Here I have taken FOB, here FOC and here is FOA. Suppose this is here taken x and y axis, x dash and here y dash. This angle is 120 degree, this angle. So when we make here, this angle will be coming here 30. So here this is 30 and this is 30. We can write its component FOB cos 30, FOB sin 30, FOC cos 30 and FOC sin 30. These are the components of the forces. Now we can solve along the x axis. So we can get Fx is equal to total force along x axis is equal to FOB cos 30 I cap plus FOC cos 30 minus I cap. Now here we can write FOB is equal to magnitude of FOC is equal to here FOA is equal to 1 upon 4 pi epsilon naught Q upon OA square. So, see here OA, OB, OC are equal. So, therefore, the forces, all this, the magnitude of the forces will be equal. So, we can calculate this Fx. So, we know it FOB, FOC are equal cos 30, this is minus I cap, this is I cap. So, we can write here Fx is equal to 0. So, net force along x axis is 0. Similarly, we can write net force along y axis FOB sin 30 j cap plus FOC sin 30 j cap plus FOA minus j cap. This is this side here. So, that can be written minus j cap. Again here FOB, FOC and FOA are equal. So, we can write here sin 30 is 1 by 2 and this is 1 by 2. So, we can write here FOB 1 by 2 j cap plus FOB 1 by 2 j cap minus FOA j cap. So, in place of FOC I have written FOB, and here in place of FOA I am writing FOB. It means all are equal. When you solve it, you will be getting here 0. So, total force along y axis is also 0. So, the net force experienced by the charge placed at the centroid is equal to here 0. Now, see here, there are two charges, one is suppose here proton, another one is electron. This is separated by a distance of 1.6 centimeter. You have to calculate the forces between these, force between these two, proton and electrons. We know the charge of an electron is minus 1.6 into 10 raised to power minus 19 coulomb, and charge of proton is plus 1.6 into 10 raised to power minus 19 coulomb. R is equal to given to you 1.6 centimeter, that is 1.6 into 10 raised to power minus 2 meter. Now, force can be written here F is equal to 1 upon 4 pi epsilon naught magnitude of Q1 and Q2 divided by R square. So, F is equal to 9 into 10 raised to power 9, that is the value of 1 upon 4 pi epsilon naught, into 1.6 into 10 raised to power minus 19 into 1.6 into 10 raised to power minus 19 divided by 1.6 into 10 raised to power minus 2 whole square. So, now when you solve this thing, everything will get cancelled, like 1.6 into 1.6, that will be cancelled by these two, and this minus 2 minus 4, the power will be also getting cancelled. So, when you solve this thing, that is Newton, you will be getting 9 into 10 raised to power minus 25 Newton. And there is one is positive charge, one is negative. Here positive electron we can take, charges are equal, so we can add plus C and minus C. So, this there is a positive and negative. So, we can write here the nature of the force is attractive. So, we can calculate the force between the two charges using Coulomb's law.